So, synchronized data for audio plugins. Thanks for coming to my talk. Just a quick bit of background on me. I founded a company called Node Audio. We do development services and build plugins. I've been an audio developer for about 10 years now, and before that, my background was in server-side web development. So what is synchronized data? What do I mean by synchronized data? I realized talking to a few people before the talk that this might be a bit ambiguous. What I mean by synchronized data in this context is, so data can be documents, songs, preset settings, etc. Things, basically stuff that you have saved related to your app or your plugin. And the synchronized bit is synchronizing that data across devices. So that tends to look like this. So you have, got to point it, so you have device A and device B and server, and the data on device A looks like the same as the data on device B because they're being synchronized via this server. And you could also have a web application coming off that server and seeing the same data. So there's sometimes also is becoming a thing peer-to-peer, where you don't need a central server. You can synchronize between devices, which can be interesting when there's no internet, for example. But before we get into it, why bother? Why do you want to synchronize? Why is it interesting? So the reason I started looking into this was when I was first getting into audio development, I was working on a tuning app, a microtonal tuning app, and I wanted users to be able to have the same tunings that they'd created or edited available on different devices and in plugins, etc. So that was how I started looking into this. And the kind of pain points this kind of data synchronization can solve is, for example, you want to copy a preset. You've come up with this really cool preset on a complicated synth. Say it's running on an iPad, and then you want to use that same patch on your laptop. How do you get it from your iPad to your laptop? Okay, there are ways to do this. You can use iCloud. You could work out where the file's been saved, email it to yourself, and pick it up on the other machine, but it's fiddly. There are better ways to do these things. We've got used to this stuff with things like Google Docs, for example. If you wanted to share that preset with your friend or a bandmate or someone else on the internet, similar thing. You need to work out where the particular plugin or app has saved it, pull it out to an email or some messaging app and send it to them, and they need to do the reverse, put it in the right place for it to be picked up. It's doable, but it takes you out of the flow. It doesn't have to be that complicated. Another useful aspect of this kind of synchronization, apart from user-specific data, is, for example, if you've shipped a plugin with a load of factory presets that you've spent ages refining and they're a big part of your product, and you realize one of them's broken after you ship, or there's one you forgot to add, or something like that. With this kind of setup, you don't need to worry about that because you can just update it on your server, and magically everyone who comes online will get the updated version. Another useful side effect of this is you get backup for free. So let's think about what an ideal solution might look like. And I'm going to start by thinking about it from the user's perspective. So as a user, basically, I want to see the same stuff on all my machines, all my devices. So, I might have a desktop machine in my studio. I might have a laptop that I take out. I might have an iPad that I jam on sometimes, for example. I want to see the same stuff on each device whenever I log in, and maybe even on the web. So I also don't want to have to be online to use it. So I want to be able to be, away off the internet for a while and do stuff. And then when I come back online, everything automatically updates. That's what I want. That's what people expect now. And sometimes there might be conflicts. So ideally, I want those conflicts to be resolved automatically. I'm going to go into what I mean by conflicts in a bit. So that's from the user's perspective. Okay, in terms of the specific requirements for us audio devs and for audio plugins, firstly, I'd like it to be cross-platform. I'd really like it to have a C++ API, because most of us are writing stuff in C++ here, or even a C API that I can wrap. And I need to be able to, I need concurrent access. What I mean by that is, for example, you have multiple instances of a plugin that might be running in different processes that might be trying to access this data at the same time. You might even have the same database being accessed by different plugins or apps. So concurrent access is really important. Thread safety is would be nice as well. So at least, you know, whatever I'm using doesn't allow me to do anything silly across threads or handles that stuff itself. So we also have some general requirements. So you might want to have a differentiation between user-specific data, like how do you sort of portion out that the user's data, and you might want to have some what I call public data, like factory presets or settings or help files and things like that. And yeah, I want to be offline first. That's what I mean by you should be able to use a thing offline without needing to connect. I would also like to have access to this thing on the web, so I can build a web page that accesses the same data, and I might want to build a mobile app with native mobile APIs for mobile developers to access the same data as well. So this is a summary of the main things we want as developers, or that I wanted as a developer from this kind of solution. And so let's think about potential solutions, how we might start building something or using something. So basically it's build your own thing, custom solutions, or third-party solutions. So if you're going to roll your own, if you're going to decide, okay, this can't be that hard, I'll just put something together myself. Okay, so one of the things that you will need to consider if you want to try building something like this yourself is what to do about conflicts. So conflicts are basically like, a lot of you, I guess, use Git. So it's like that kind of thing. You know, you change something in one place, you change a similar thing in another place, and then when you put them together, they don't fit. So what do you do about that? So yeah, as to illustrate this, you have device A, which is offline. You make an edit to a document, let's call it. And then device B makes an edit to the same document, but a different edit to the same bit of the same document. And then and then device A connects to the server and synchronizes, that's fine. Everything's updated. Then device B tries to synchronize and it doesn't work because the things don't match. There's a conflict. So there are various ways to resolve this. There's, you can take a simple approach of like the most recent one wins, or you can ask your user. So that's probably one of the harder problems to solve in this area. Then it's how do you deal with user-specific data? How do you push it? Where do you put it? Then you might want to think about authentication, especially if it's like security-sensitive data. Do you kind of have a log of all the changes that have happened so you can roll back if you need to? So the most simple, naive implementation of this sort of thing could be you just save, if you're using Juice, you're probably saving your presets as XML files. You just save that and upload it to a server, or send the XML via REST API and just have that on a folder on a server somewhere. That can work for a really simple use case if you don't want to worry about conflict resolution or it's not important. There's some other stuff I've looked into, JSON synchronization using something called JSON patch, which is a little bit like Git in terms of Git patches. So it kind of just describes a particular change to a JSON object. Something I discovered while, my time researching this stuff, the SQLite session extension. I'll go into a bit more detail about that in a little bit. Basically, it logs the changes that you apply to your database. Then it's what's called conflict-free replicated data types. So these are commonly used to kind of log changes that can then be synchronized together. It's very much like Git, actually. So that's that's kind of like ways you could implement this stuff on your own. I'm going to give you a brief history of my research into this area over what I realized for the last 10 years. So it all started in 2014, 10 years ago, when I was working on my mobile app. It's called Internal Tuner. It's a microtonal tuning app, and I wanted to have a database that one day would synchronize with a plugin that I was going to build, which took me about 8 years to actually get to build that. So Couchbase Lite was the thing that I came across. It was kind of the only thing that at the time, could potentially be used from C++, but they didn't have a C++ API. I started building this app purely in Juice, and then ended up using native APIs, but that's another story. So Couchbase Lite at that time synchronized with CouchDB. CouchDB is a really lightweight database. You can run it very cheaply on a DigitalOcean server for about $5 a month. It also synchronized with Couchbase Server and their synchronization service called Sync Gateway. Couchbase Server is like a full-on enterprise database designed for what they call high throughput. So great if you're an airline or something like that and you've got tons of data being put through, you need to synchronize it. But it's really overkill for like synchronizing presets that you might save once in a while. Also, Couchbase Server is very expensive to run. It needs at least 16 gigabytes. They recommend 16 gigabytes of memory for it to run smoothly. That's just for the server on its own, and then you'll need to have the synchronization service possibly running on another server. So gets a bit expensive for small projects at least. So I ended up using Couchbase Lite and CouchDB for this project. It's still going. I've just mentioned this. So CouchDB basically is cheap to run. Couchbase Server is expensive. Then a few years later, after I was well into developing the mobile app, I think I'd released it or was about to release it at this point. But still thinking I want to get this stuff into a plugin at some point. So Couchbase announced Couchbase Lite 2 is coming, and it's going to have this C++ library, core library, and I was really excited. And I started diving into this undocumented C++ code to try and use it with my project. And, I was getting there, but I came across a few issues and posted on their forum, and then they told me, this is unstable, this is not meant to be used, it's just an internal C++ core. Then we're going to have all our platform-specific wrappers and with Objective-C and a C# on Windows and Java and Android, etc. The other thing they did was they dropped support for CouchDB in Couchbase Lite 2. So I was like, okay, now I can't use this cheap-to-run CouchDB. I have to use Couchbase Server, which is expensive. So I just left that alone, thought, okay, I need to put my thinking cap on and work out how else can I solve this problem at that time. A couple of years into that, I started working on Internal Studio, which was the plugin that I'd been planning for years, and came across a project called Flip, which was really interesting. So Flip, it's basically a library designed for real-time collaboration. And it was developed by people from OhmForce, who created Ohm Studio, which was a collaborative DAW that sadly is no longer. And we had a few calls, and we were talking about licensing this library for use in Internal Studio, mainly just for the synchronization aspect. But then I realized it's like this, I don't need real-time collaboration. This is overkill for what I need. So carried on searching. However, what I did find in Flip, digging into their code, I saw they're using SQLite. So up until this point, SQLite was not interesting to me. It's kind of one of those really boring things. But when you start looking into it, it's a really amazing project, actually. So that's got me looking into like, how could I use SQLite for this thing? Okay, maybe. Then I around the same time, came across a project called LightSync, which is kind of an extension of SQLite and replicates or synchronizes different SQLite databases between themselves. So they connects them together and then they synchronize their data. But couldn't use this because each instance, the concurrency thing did not work here. So yeah, concurrency not supported, so that's out. And then I discovered the SQLite session extension, which was like, this could be interesting. This could be something we could use. So basically what it is, it's a log of all the, the session extension allows you to log all the operations that have happened on a database. So inserts, updates, deletes, etc. And package them into a binary blob, and then you can take that binary blob and apply it to another instance of the same database. And it also allows you to define a function to deal with conflicts if they occur. So this looked like, okay, this definitely could be a solution, a way to build such a solution. But then I started thinking, okay, how would we synchronize this with the server? I don't want to have to run SQLite on a server. SQLite is designed to be on devices, not to live on a server, having lots of connections from the internet. So kind of abandoned that, got a very basic, almost proof of concept, and then abandoned it because, I got sucked into other things. Then I discovered a project called AmpliSync, also known as SQLite Sync. That looked very promising, by a Polish company called AmpliApps, and that synchronizes SQLite, a local SQLite database, with Postgres, and I think they've also done like MS SQL Server connections. So it's designed for mobile apps and web apps, and I got in touch with them and said, your solution looks great, it just needs a C++ client. Are you up for working together to build something? And they were. So we started doing that, and we got to a proof of concept, but in the end I abandoned it for a few reasons, partly because I then discovered RealmDB. So RealmDB has been around for a long time. It became a very widely used database for mobile applications, partly because of its synchronization capability. And I remembered I'd seen a few years ago, there was this Realm CPP project, but at the time it was only working on Mac OS. So no Windows support, so I was like, that's out. And then I found it again, and it was like, okay, this has become mature. They're like in sort of late alpha stage here, and it was usable. So I dived straight in and started integrating it into Internal Studio, and it was looking good. I found bugs here, issues there, and I went onto their GitHub and hassled this guy called Lee McGuire, who was the maintainer, and he was very responsive, and things got fixed and sorted, and after 2 or 3 months, it was working. Very, very happy about that. And this is what it looks like. So if I can...
Here we have Internal Studio running as a plugin in FL Studio on Windows, on a MacBook, and on iOS, and on iPad. So I'm now going to create a new tuning here. So temperament 17. T17.
So I'm just creating something and saving it there.
So that's now saved there. And let's see, it's now appeared here. So we can load it up.
Excuse the jiggly mobile recording.
And it's appeared here on the iPad. So we can load it up there. Now, let's say we want to edit this scale. So we're just going to delete a load of intervals, reduce it. That doesn't have so many notes. Okay. So there's a reduced version of it. And I'm now going to save that. And here, if I just go to reload that,
I have to reload it.
Reduced version there. And if I load it again here, if I load it again here, there's the reduced version on the iPad. And now, if I don't want it anymore, I can just delete it. So, I'm deleting it from the list there. And it's immediately disappeared from here. And not quite yet. It crashes.
And then it crashes.
It crashes.
I left that in just for the joke. So then, very sadly, the whole thing has been deprecated. Yeah. So I was going to do this talk with Lee. He was going to do the last bit of the talk, going into technical details about RealmDB, blah, blah, blah. And he got in touch with me, I think it was on the 10th of September, and said, I'm really sorry, I don't think I'm going to be able to do this talk with you because the whole thing's been deprecated. There you go. that day I started going online, going, what the hell's going on? Very strange situation, a super amazing mature project. And what they've done is they pulled this bit, the device sync bit, so you can still use Realm CPP in the database as a local database, but kind of what's the point if you can't synchronize it? So that's what they've pulled, the whole synchronization service. Well, they haven't pulled it yet. It's been deprecated, and it's going to be pulled out of action on September 2025. So I was really close to delivering a beta with all this stuff and can't do it. So what now? Okay, so MongoDB kindly, after putting this, said, oh, there's some other stuff you could use. There's some other projects. So there's one called Ditto that they recommended. But it's not really ready. It's got, I found a C++ library, but it's Linux or Android only. There's a Rust library. I could use that. Mac OS or Linux only. Nah, okay. Ditto's very focused on the peer-to-peer synchronization, which is quite interesting. It's a total proprietary database, but we can't use it. PowerSync, a really interesting project that's gaining momentum. It doesn't have a C or C++ library yet, but I think it will at some point. The thing I like about it, because there was a lesson I learned from this experience with MongoDB, is like you're relying on, when I saw that RealmDB was bought by MongoDB, and that was like, oh wow, it's being taken care of by this big company, so everything is safe, great. No. Something that's based on, non-proprietary technologies like SQLite and Postgres, that no one's going to pull those, right? And they're basically free to use. So something that's based on those is quite attractive. So PowerSync it's an SQLite extension, similar to the session extension. So they've told me they're planning to sort of put all the functionality directly into the extension, so then it will be quite easy to use it from C or C++ because it's basically SQLite. But because it's not ready yet, it's not ready for me to use yet. So crossing that out. Then I looked at Couchbase Lite again. Okay, it's matured now. There's now a C++ library. There's a C library with some, C++ header wrappers. So the documentation is okay, but you can work it out. It's kind of a proprietary database, but it's actually interestingly based on SQLite is at its core. It still synchronizes only with Couchbase Server. But okay, I'm interested in it again. A new contender is called ObjectBox, and that is based on a C++ library. It's very much aimed at the automotive industrial kind of industries. It's also its own totally proprietary database, and it syncs with other ObjectBox instances, and they're working on a MongoDB connector. So let's go into a bit more detail about these two options. So Couchbase became really interesting because now they've got a free tier. They've got this Capella service, which is like a database as a service thing. So you can use one node. They have these clusters of nodes. They've got a free tier now. So you could probably do most of what we need in terms of like preset sort of stuff with their free offering. If you want to go the next level, it's like about over $1,000 a month for this service. Just like, why? I don't understand why there needs to be such a big jump. Okay, you can also run it on your own servers, but even then, it's you're looking to $100 to $200 a month minimum. Couchbase is great in terms of user-specific data. So you've got collections and scopes, which allow you to have, you can have app-specific collections, and you can have a collection or a scope per user. So it's really good for organizing your data in different ways. It's schema-less. You can kind of define types and stuff, but you don't have to. So it's quite nice if you're, say, working with value trees and converting them and saving them to a database like this, because your structure might change, your types might even change, so you don't need to worry so much about coming up with the schema ahead of time. There's also a possibility of peer-to-peer with Couchbase Lite. Let's go back to ObjectBox. So ObjectBox is kind of great actually, because it's a kind of small company, but they seem really committed, and it's being used in BMWs and stuff. So and I had a call with their CEO a couple of weeks ago. They seem really committed to kind of improving this, and especially since the MongoDB fiasco, they're now working on a connector to MongoDB, which is in alpha stage at the moment. ObjectBox is also nice because it uses very few resources. It's like they built it as an alternative to SQLite, but with a sort of no SQL approach. So it's they're designed to sync with other ObjectBox instances, but you can run them on a server. They're designed to accept lots of connections, whether they're running, on a server or kind of embedded in an application or a plugin potentially. The current issue and the main sort of thing that concerns me about it at the moment is there isn't support for user-specific data. Although they told me they're working on it, they've been thinking about it for a long time, and they're hoping that it will be ready by first quarter of 2025. There are workarounds, so depending on the type and volume of the data, like basically what ObjectBox does is like the whole data set is synchronized. But you can query the data. So you can synchronize all your data and you could just query the stuff that you need. So for example, you might have, in my case, all the tunings that exist for everyone would be synchronized, but tuning data is tiny. So that's probably okay. Yeah, and in terms of the schema thing, you need to define your schema ahead of time. It's actually based on flat buffers, which is one of the technologies I was looking into when I was thinking how to implement this myself. So it's interesting that they used it as well. So yeah, you need to define your schema definition using flat buffers. So it's kind of fixed, but there's also this flex type. So if you need to have types that are like not, that you want them to be flexible, like, like var in value tree. And it supports peer-to-peer, which is really, I'm really interested in that option. Another thing, so I'm just gonna finish up now. So basically these are the options now. These are if you're looking for a library to synchronize data in a plugin, these are pretty much your two options right now. Another thing that Vivian, the CEO of ObjectBox, mentioned to me at the end of our call, she said, "Oh yeah, by the way, we can do vector search." I was like, "Oh, I've heard that term. It's become a bit of a buzzword term, but I don't quite know what it is." So I looked it up. It's actually on the Couchbase site that I got this definition from. So basically, what it could mean for us audio developers is, for example, you could say if you've got a sampler, you've got loads of samples, and you want to find samples that are similar to each other. So you could run some analysis on your samples, and you could save the results of the analysis in what's called these sort of vectors. And you can, within both of these databases, you can run a similarity search. So I was like, okay, that wasn't what I was looking for, but something interesting that might be interesting to some of you. Yeah, that's the final slide of my talk. Thank you for listening. Thank you for your time. And any questions?
Let's give it up for Adam.